In the previous video, we have seen voltage doubler, which takes a sinusoid of peak Vm and gives an output of 2 Vm. And in this video, we're going to see voltage tripler, which will take this sinusoid input and give an output of 3 Vm. And we will also discuss voltage quadrupler, which gives 4 Vm as an output. Let's start with voltage tripler, whose circuit diagram is shown here, which consists of 3 diodes and 3 capacitors, and its input voltage is shown here, whose amplitude is Vm. Now, as always, we assume that all the capacitors are holding no charge, which means the voltage across them will be 0 to start with. Now, when we apply the input voltage, if you see at t is equal to 0, the voltage is 0, and as t increases, the input voltage is going to be positive. When it is positive, the voltage across the diode D1 will become positive, which makes D1 short circuit. Let me draw that circuit here. D1 is short circuit. Hence, the voltage across this point will be 0 volts. When it is 0 volts, obviously it doesn't matter what happens in the rest of the circuit. Now, because of this, as the input voltage is like this, positive on upper side and negative on lower side, as the diode is conducting, which will allow current to flow through, and let the capacitor charge and follow the input voltage. Now, the input voltage, as it is increasing, the voltage across the capacitor also will increase, and it reaches to a peak value of Vm. Even the voltage across the capacitor would reach Vm. Once it reaches Vm, the voltage at the P side of the diode would become Vi minus Vm. So, till this point of t by 4, when t is in between 0 and t by 4, the voltage across the diode D1 is going to be 0. When t is greater than t by 4, the voltage across the diode would be Vi minus Vm, which makes the diode reverse bias, because once the input voltage decreases below Vm, Vi minus Vm is going to be a negative value, which makes D1 off. In the initial case, we had D1 on, here it is off. So let me say the first case we have seen here is when t is in between 0 and t by 4. Now let's move on to the second case where t is greater than t by 4, where D1 is off, which will be open circuit. But as we know, the voltage at this point will be Vi minus Vm, and the voltage across the capacitor is going to be Vm. This Vi minus Vm is going to be in between 0 and minus 2 Vm, because Vi is going to change in between minus Vm to plus Vm. When we substitute plus Vm, it's going to be 0. When we substitute minus Vm, it will become minus 2 Vm. Which means the voltage across the diode D1 after t greater than t by 4 is going to be Vi minus Vm, which means the diode D2, which is following this, N side will be negative and P side will be positive. As a result, the D2 will be short circuited, as it is going to be forward biased. Now, as this node has voltage Vi minus Vm, which means the voltage across D1 is going to be always negative, hence I am going to mark it minus plus, which will make the current flow through this circuit this way, which will make the capacitor charge positive on left side and negative on right side. And now if you look at this, the voltage across D1 is going to change from 0 to minus 2 Vm, which means the maximum voltage to which the capacitor C2 will get charged will be 2 Vm. Now, to understand what happened to the voltage across the diode D1, let me draw that 0 to t by 4, the diode D1 was on, hence the voltage across it will be 0, and afterwards it's going to be Vi minus Vm. At t is equal to t by 4, Vi is equal to Vm. Vm minus Vm is 0, so we are starting at 0. And the voltage is going to go down all the way till minus 2 Vm and come back up to 0 and goes down again. So the sinusoid is shifted downwards. So let me represent that this is still T by 4, and beyond which it's going to be Vi minus Vm. Now similarly, if you look at the voltage across D2, it is going to be 0 when the diode is on, but when the capacitor gets charged to peak value 2 Vm, we are actually at this point, which is in fact a T by 2 here. So hence this point is going to be 3T by 4. So the time duration that we are seeing is T is in between T by 4 and 3T by 4. So let me represent that in the input waveform. That is, in the first case, we took only the quarter of the time period to charge C1 to Vm. In fact, in T by 4 period, the voltage changes from 0 to Vm. So the capacitor got charged to Vm. In the next half cycle, that is in this duration where the time period is between T by 4 to 3T by 4, the capacitor C2 got charged, and of course the voltage has changed from plus Vm to minus Vm. The overall change is 2 Vm, which actually charged the capacitor C2 to 2 Vm. So let me represent that here. C1 is charged. In both of this, in this region, C2 got charged. Now when the capacitor C2 gets charged to 2 Vm at T is equal to 3T by 4. Now the voltage across the diode D2 would be Vi minus Vm, which is the voltage at the N side of diode D2, minus the voltage on the P side, which is minus 2 Vm. If you look at this, this is Vi minus Vm plus 2 Vm. This is Vi plus Vm, which means the voltage across the D2, as pointed out here, plus on N side and minus on P side, is always going to be positive for any value of input Vi, which means the diode D2 after this point is going to be open circuit. So hence, we'll take the third case where T is greater than 3T by 4, in which case both D1 and D2 are going to be open circuit throughout the operation beyond this point. So hence let me draw the circuit, and we have seen that C1 got charged to Vm and C2 got charged to 2 Vm. Both D1 and D2 are off, and we have here Vi, and we know the voltage at this point, that is Vi minus Vm, and here the voltage is minus 2 Vm. And we have talked about that the voltage that we see here will be Vi plus Vm. Now when the voltage across D2 is going to be Vi plus Vm, the following circuit, if you see that the capacitor and the diode D3. The diode D3 is going to get all the time positive voltage because Vi plus Vm is always going to be positive. Hence the diode can be taken as short circuit as it is forward biased. Then the capacitor C3 would get charged and it will go to 2 Vm, because if you look at the voltage across these two nodes, that is the voltage across D2, peak to peak value is going to be 2 Vm. Hence the capacitor C3 gets charged to 2 Vm. Now if you plot the voltage Vi plus Vm, which is going to be 0 from 0 to T by 4, and of course we have seen in the period T by 4 to 3T by 4, diode D2 is on, hence till that point also it is going to be 0, and afterwards it reaches its steady state value, which is Vi plus Vm. Hence the voltage would be like this. Now to hit another peak value, in fact that is the time by which the capacitor C3 will get charged to 2 Vm. This time period or region will be again T by 2. The voltage change will be 2 Vm. Hence we can say the third case that we are looking at is in between 3T by 4 to 5T by 4. Once the capacitor C3 gets charged to 2 Vm, we have to see what is the voltage at this point. Of course, within this time region, the voltage across the diode D3 is going to be 0, but once the capacitor gets charged to its full value 2 Vm, then the voltage at this point, we can say that is for T greater than 5T by 4, the voltage here, let me call this as V3. V3 will be equal to Vi plus Vm minus 2Vm. So V3, which is the voltage across the diode T3, will be equal to Vi minus Vm. Of course, its maximum value will be 0 and minimum value will be minus 2Vm, which means the voltage across the diode after T greater than 5T by 4 is always going to be negative, which means the diode D3 will be reverse biased for any time greater than 5T by 4. In fact, if we look at all the scenarios, after 5T by 4, all the diodes will be open circuit. Only the capacitors will be charged to its full values that they see. So let me say this is the fourth case. The circuit diagram would become like this, and I'm mentioning the voltages that will be across the capacitors. That is Vm across capacitor C1 and 2Vm across capacitor C2 and 2Vm across capacitor C3. Now the voltage across the diode D1, let's call this V1. V1 we found it to be Vi minus Vm. Voltage across the diode D2, V2 is equal to Vi minus Vm minus of minus 2Vm, which is plus 2Vm, which is equal to Vi plus Vm. And the voltage across the diode D3, which is V3, is equal to V2 minus 2Vm. V2 is Vi plus Vm minus 2Vm, which is equal to Vi minus Vm. These are all steady state voltage equations. Now if you observe all the steady state voltages that we got here, V1, V2 and V3, the diode D1 is clamping the voltage downwards because we have a minus Vm. The diode D2 is clamping the voltage upwards plus Vm, and diode D3 is doing a clamping downwards, which is minus Vm. So if you look at the circuit, now every time for this kind of circuit we cannot be doing this elaborative kind of analysis. So let me represent one more thing here, that is in this region that diode D3 was allowing the C3 to get charged. Let me write this here. C3 got charged. And after this point, which is 5T by 4, we are in steady state where capacitor C1 got charged to Vm and C2 got charged to 2Vm and C3 got charged to 2Vm. And always remember that the diode symbol itself has the arrow mark direction indicating that it will allow the current flow. So when a circuit is given, we can see that D1 was allowing current to flow through this way, hence the capacitor C1 got charged in that way. That is positive on left side, negative on right side. So when we go to the second one, the diode D2 will allow the capacitor to charge if current flows in this direction, indicating the current arrow mark direction of the diode. Then capacitor C2 will get charged this way. And coming to the third one, that is diode D3 will allow capacitor C3 to charge this way, indicating the arrow mark of D3. Hence the capacitor C3 gets charged this way, positive on left side, negative on right side. Now coming to the main question, how is it a voltage tripler, right? So if you take the voltage across this points, now we have Vm plus 2Vm, which is plus on this side, minus on this side. The output voltage will be 3Vm. In fact, the circuit can be directly used as a doubler as well if we take the voltage across this, that is 2Vm. Now let's think about how do we make a voltage quadrupler. Obviously, it is going to be very straightforward. That is, only the first stage is going to charge the capacitor to Vm, and every other stage is going to charge the capacitor to 2Vm, but the diodes are actually changing directions. Because for the first capacitor gets charged in T by 4 and every other capacitor gets charged in T by 2 period. Now we need to add one more stage here. So let me draw the voltage quadrupler. This is how a voltage quadrupler circuit would be. We have just added one stage extra compared to the voltage tripler we have seen. Now we can directly tell how the circuit is going to work. That is 0 to T by 4, obviously the first capacitor C1 gets charged to plus minus Vm, and in the next T by 2 we're going to have the diode D2 conducting. Of course it will take extra T by 2 time period, which will make the capacitor C2 gets charged to 2 Vm, and then diode D3 will conduct, which will make the current flow this way. Hence capacitor C3 across voltage would go to 2 Vm, and after that in another T by 2, the D4 would let the C4 charge in this way, that is plus minus 2 Vm. Now if you look at the voltage across these 2 points, positive on this side, negative on this side, the voltage across this will be equal to 2 Vm plus 2 Vm, which is 4 Vm. Hence this is a voltage quadrupler, and we can go on expanding this if we want to get more and more multiplication factors. So hence we can design a n voltage multiplier by just extending the stages. So if we observe here, the first stage has capacitor on top side, diode pointing downwards, and the next stage has capacitor downwards pointing diode upwards, and this structure keeps repeating again and again. If you like the video, please give a thumbs up. If you haven't subscribed yet, please do subscribe, and thank you for watching.